Okay, I am so tired. Yeah, I'm so tired. It has been like countless times since I've said today's live stream is going to be less than 2 hours, less than 1 hour, and surpassing 4 hours, 6 hours, even 10 hours. But this time, I think I really am going to make the stream less than 1 hour. Hmm. This time for real though, my body cannot handle it. Okay, background music. Yeah. Oh. What the fuck? Hold on. Okay. Hmm. Oh. I'm just doing something very important. It's very important. Very important, and you might be wondering, well, you could have done earlier before the stream started. No. I have to do it right now. Okay. Yeah. Well, let's talk about a small talk. Talk about a small talk. Yes, it's like Inception talk something. No. I have been doing something a lot recently. The Pararang behind the screen that you cannot see is really busy person. Well, sometimes I'm mostly busy. Sometimes I'm really far away from busy person. Yes. Complete opposite to the busy, which is a lazy sloth person. I just have two different sides. Very sloth-like and less sloth-like. Normally, if I just brag about this subject, and then this stream would go for like 2 hours long because I somehow cannot find my own way to shut up. So we're just gonna go right into it. Okay. Oh yeah. Okay. Let's just forget all about this. The last time we learned about the eccentricity, I reviewed some parts. and I reviewed some parts and I reviewed some stuff that will be really helpful to understand the exact depth of the eccentricity. And of course, what am I doing? Yeah. So there was something called like this one. Colors a little bit funky. Oh yeah. This was the semi-diameter axis, and this was the linear eccentricity. And it basically went like this. Yeah. I'm gonna start out with the ellipse. No, circle. Why not circle? Okay, circle. Yeah, and normally I would draw the curves at the center at the origin of the diagram, of the grid. But the reason why I draw it like this is because... Oh yeah, it's because I realized something. And that is a thing. The eccentricity is a value according to ratio. This one, linear eccentricity, is a semi-diameter axis, semi-major axis. Yeah. And according to the definition we have seen the last time, the linear eccentricity is the length of the locus point, the focal point. Should be this one. No. Yeah, I'm getting confused again. No, wait a minute. Okay. Linear eccentricity of the circle was 0. Linear eccentricity of the circle was 0. Circle was 0. Because major axis was not normal. Over the linear eccentricity is the thingy. Yeah. Okay. It is right here. Yeah. Ignore this curve. Ignore. Yeah. Doesn't exist. And we're gonna focus on this one. This is the center of the circle. Yeah. If you're watching this from the future and you're like sort of a mathematician, has a doctorate degree, and feel free to correct me. Yes, and if you have a degree lower than doctorate, then shut up. Okay, so this I'm gonna name the center of the circle. Yeah, okay, just in case I'm gonna. Yeah. So the linear eccentricity is between the center and the focus point, which is 0. And the linear eccentricity, I'm gonna name it F, which is 0. And the semi-major axis, the radii, is R. So the 0 over R is 0. That's why the eccentricity of the circle was 0. And now the fun thing starts here. Yeah. So what I realized while reviewing the last stream, this is not one focal point. Let's just say that there are 2 focal points that are close to each other, really infinitely. Yeah, really infinitely close. Near 0 is what this is. So what we're gonna do is we're gonna pull this one focal point infinitely. Yeah. And that's when it becomes the circle becomes oval shaped into an ellipse. Yeah, like this. And when you oh god. Yeah, when you really pull it really hard, but it somehow surpassed the thin plane of ideal and real plane, the plane of existence and non-existence, and somehow you managed to go through that plane, like the one episode in Marvel's What If Season 3, which somehow ended up into Captain Carter Misadventures. I'm not gonna say something about that, but yeah. Then the curve will turn into like this, into a hyperbola. Hmm. Well, since I spilled out the beans about the Marvel What If Season 3, I'm just gonna say only one sentence, even though I want to say a whole paragraph. I was disappointed. I was disappointed. And that's one sentence. Yes, okay. So, it turns out to be like this. The one focal point comes around, and it comes right here. Is the thingy, yeah. Oh, I'm not quite sure if this the thingy, this focal point coming in this direction is actually this focal point coming around, because I'm not actually quite sure about the plane of this, the ideal part. What is this even called? Yeah, I forgot what this is called. The plane, according to this, I know that's the focal point coming around in this direction has to do something about this concept, but too bad I suck at English and I don't even know how to write my own name in English. I don't know how to speak that. So, but between these two eras, between those two, there are an exact single moment. I mean, really exact single moment right before this focal point decides to join in this direction. Yeah, which is a parabola. Yeah, the thing that I have shown you guys on the thumbnail for today's live stream. So this one focal point from the circle goes in this direction. It turns the ellipse, turns into a parabola, and right at that moment it turns into hyperbola. Yeah. And one single point. Okay. So the eccentricity of the circle is 0. But here in the eccentricity, the eccentricity is this is the center. The eccentricity, this is the linear eccentricity, and this is the semi-major axis. It is not 0. The linear eccentricity is not 0. Therefore, it is like 0 point something, I don't know, because the semi-major axis is still bigger than the linear eccentricity. And in the hyperbola, oh god, how did I do this? Here is the center. Here's the center. Yeah, let's say this is the center. Then the linear eccentricity, this one, and semi-major axis is this one. And as you can see, the linear eccentricity is bigger than the semi-major axis. That is why the eccentricity of the hyperbola is over 1. Yeah, 1 to something something, or even bigger, like 2, 300, like that. Yeah. Ow. So, we can guess then what the eccentricity of this thing would be. Yeah. Actually, we don't actually have to guess. Actually, guessing is even more unintuitive and difficult than calculating. I'm gonna explain why, but let's say that we can guess what the eccentricity of the hyperbola is. So, circle is 0. Ellipse is 0 point something. Hyperbola is over 1. Yeah, then we can guess the ellipse of the hyperbola is 1, and it is actually 1. Well, this is not a big surprise. Yes, it's not something like you open up a Christmas present under the Christmas tree at December 24th, which Santa didn't even arrive at then. it would be a surprise. But the hyperbola eccentricity number 1 is less surprise than that. Anyway, no, the hyperbola eccentricity is 1. Yeah. Wait a minute. Yeah. Okay. So, eccentricity is 1 in this scenario. And the reason why the value of the eccentricity of the hyperbola is 1 is because that's the definition. Yeah. I'm not saying that when you want to describe hyperbola into elementary school student's brain, I'm not saying that you would start with the eccentricity value is number 1. I'm not saying that. It's just that, like I said, like I showed you guys earlier, extend the focal point, and the eccentricity value will eventually increase, and it would eventually reach to a point where the eccentricity value is 1. Yeah, and that's it. And we just named it parabola. Yeah. So that's basically it. Parabola eventually forms. The point where the eccentricity value is 1 will eventually come. And we just named it parabola. Yeah. And the disclaimer right here, I am not a major in math, although I was kinda good at math. My major is bio-nano-engineering. Yes, it takes like 3 days to explain what actually that is. So it might sound like that I'm like kind of scamming to you guys, scamming math. If you're thinking that way, you're absolutely correct. So this is parabola right here. And when I first learned about the parabola, is that there was this line in here, and there was this focal point. And the parabola is the locus of points with the condition where this value and this distance value is equal. Yeah, so like in here, this one and this one is equal. So probably here, this one, no, that's 12. Yeah, this one is also equal. And the locus of these points is considered as parabola. Yeah. And now I know it makes sense. Because now we know what the eccentricity is. Wait, did I disable my... Oh. Where's this shit? Okay, hold on. Never mind. Okay, here we go. So. Directrix is what is called directrix. There's one directrix. Boom. One directrix. And wait a minute, how did it go? One directrix, and there was another one. Yeah, okay. start from here. Yes. And as you can see, this looks like a dot, but it actually isn't. Yes. Pull up your, what's that called? Binoculars. Yes. I forgot what the thing called. The binoculars are for looking at the stars, which is very far away. What is the thing? What's the instrument that's called to look for smaller things? Telescope. Binoculars. Anyway, just open your eyes really wide and you'll just see that this is a circle. Yes, this circle. This circle in a very, 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 very like Ant-Man quantum-sized sort of that kind of thing size circle. Yeah, and we will expand the focal points. Like I said, there are 2 focal points. Let's just say there are 2 focal points. Yes, I'm just saying there are 2 focal points, and we're just going to extend this one into this direction infinitely, and this will, yeah, and then focal points will move in this direction in this manner, and it will become an oval, and then it will become even wider oval. It will become even wider oval. No, wait a minute. Yeah, even become crazy oval, and even more crazy oval. Then it will eventually, when this focal point moves enough further, like we have just witnessed, this will turn into parabola. And the only single thing difference that what I've just explained before is the existence of the directrix. Yeah. I also could have calculated why. So there seems to be 2 different ways of calculating eccentricity. One is the thing that I've told you guys earlier, the semi-major axis and the linear eccentrics. Linear eccentrics over semi-major axis is the one method of gaining the eccentric value. But also, you see this? This one, yeah. It's a relation of these 2 distances. From the one focal point to the point of the curve, and the distance between the point, the closest distance between the point and the directrix. So this distance and this distance, relation between these 2. Yeah, and I believe this is the thing we have seen the last time. Yeah, this one. It's basically this. Yeah. So get away. Okay. This value is equal to, let's say this is alpha. No, I'm just gonna D1 and D2 and D1. Yeah. And this will be D2 over D1. Is this correct? Is this correct? I might be wrong. I have to make sure. FP over PP. Yeah, so this is correct. So just by looking at this, yes, in my brain it was quite not intuitive. Mostly because I actually haven't delved into this deep, trying to figure out and prove myself why the eccentricity value can be obtained on those two methods and why those two are the same. The answer could be just broadly exposed in the surface, and I could be just like almost blinded and missing the almost bland exposed fact. But I decided not to go just dig into that fact because I was tired. Yeah, I believe it was like, I don't know, 4 a.m. when I discovered that. Yeah. So the eccentricity of circle was 0, ellipse for 0 point something, and the parabola is 1, hyperbola is over 1. Yeah. And now it makes sense. Because since when we almost made a stutter right there. Okay. So the reason why teachers taught that the definition of parabola was the locus of points would have the same distance, like these one and these one, like I said earlier. Yeah, it's because the eccentricity of the parabola is 1, and the one method of calculating the eccentricity is the relation between the distance between these two. Yeah, and in parabola's case, this should be equal to 1, which also concludes to d1 equals d2. So that is why the teachers taught that the parabola's definition, the locus of points, where the distance between the focus point and the directrix are the same. Now that all said, the only thing left to do is just why the equation be like the thing that I wrote on the thumbnail. Oh, Jesus. Okay. Here we go. Focal point, I'm gonna name it A, 0, with the directrix as a y-axis. This is this parabola. Okay. And here we have point x, y. Yeah. Actually, this might be actually really easy. Good for me. Yeah, I can actually go to sleep really early this time. You might not know, I'm so fucking tired right now. So the distance. Am I seeing the glitched up screen like I'm seeing right now? Oh. Okay. Well, if you're not new to my channel, there's a certain chance that you probably know that this computer that I'm using right now is almost 1 year old. Time sure does fly fast. Almost 1 year old. But I think 1-year-old computer is still young. I don't know much about the computer, but I don't think that it doesn't require to, like, you know, change that frequently. I know a lot of people would think that 1-year-old computer is a like elder PC. It needs to be changed immediately, or else you will suffer a 90 ping or something. But I don't think so. Yes. Even though the RTX 50 series has turned out to be very like efficient and very performance value as a whole, holding a very good value of performance, even compared to the 40 series, RTX 40 series. It's still expensive than the 40 series. And you know, money is the exact reason that is stopping me from doing something. It doesn't fall to the computer category. It falls to almost everything. Okay, so the PP value is X and the PF value is this. Yeah. This is actually going to be really quick stream. Right. And x squared equals x squared plus a squared plus y squared. Which will conclude to y squared equals 2ax minus a squared. Huh? Yeah, okay. Y squared equals 2ax minus a squared. This. Yeah. I know that the basic form of the parabola in this direction is y squared equals 4ax. It seems quite different from this one and this one. I think just because where this is located at. Yeah. There. Okay. Minus a squared by square root of 2x. Why is it different though? You know what? I am correct. Yes, I am correct. And this is also correct. But the point is, I am also correct. Okay. I mean, yeah, this is the thing we can derive from the process that we have just went through. There's nothing wrong with it. It's just basically a form with the y squared equals 2ax, but move to over 2 over a into x direction plus x direction. Yeah, that's basically it. And of course, there's a parabola in this direction, like this. Yeah. We can just basically just flip the y and x. That's simple. And it will turn into x squared is equal to 2ay. Yeah. Surprisingly, that is the most basic form of the quadratic equation. Yeah, sorry, I'm not quite familiar with the about the English names about the algebra. I might be very wrong. But I think you probably know what I'm saying. Yeah. So that's actually for today's live stream. I've done exactly what I did. But I think... Okay. I think I can show you guys this. Window capture. Yes, this is for the brain rot person. This is for the people who got into so many brain rot. That the person cannot watch anything if there aren't any Subway Surfers, GTA car driving, and some shit like that. Yeah. I originally thought that maybe it's a great idea to actually derive, you know, like differentiate and derive that function and maybe calculate the area. But I'm actually quite not confident about that. Yeah. So, this is the GeoGebra. Yeah, some of you guys might have heard this before. It's GeoGebra. And I'm actually not quite expert about this. But here's the fun thing. Actually, there is no such fun thing. It's a math. Yes, it's a math, and there's a... If you think it is fun, then you have problems. Okay, so... jeez, why is screen resolution always focused on my stream setup? Okay. Wow. Holy hell. Yeah, it is just basically... Oh my god. As you can see, it's y squared equals 4ax. And I'm currently animating the a value. And I didn't explain this earlier in the live stream. Yes. Animating the a value, as you can see, will differentiate the width of the parabola. And well, no shit, you look at it right here. I don't have to explain it further. Jesus. Yeah. Yes, that is it. What else can I do in here? Maybe I can do something about it. B. And oh, oh, no. Am I doing something wrong? Fine. Over. No. You know, I was about thinking animating the value, this right here, the four value. Maybe it's possible, and maybe it's impossible. Maybe I'm just so stupid. You know, maybe not. Yeah, I'm not stupid. I think the thing stupid is the GeoGebra kind of failing me to instruct on how to use the sliders. Anyway. Next corner. Oh. This one? Right. Oh, hell yeah. Oh. Hmm. Oh god. Wait, I Oh. Okay. 어, 20년째? 뭐지 이게? 어우. You know what? Maybe I should do something about it. Maybe this is not what it should be going. Is it lagging? No, I think not. It's cool though. It's very cool. Yeah. Okay, everybody just. Hey, what if I do the eccentric something, you know, the thingy? How do I do this? From the sphere to the ellipse to the parabola to the hyperbola. From the sphere to the ellipse. I can probably do that. Okay. Yeah, I might need that test. And in those two dots. X, 0. I'm thinking too hard. My alarms are ringing inside my head. My inner conscience in my brain is telling me, what are you doing? What are you doing? This is not fun. It's not fun. You scream, I want to eradicate viewers from my live stream. Yeah, I'm not gonna let that happen. But still, for a math nerd like me, it's really an interesting thing to do. I kind of really want to animate the formation that going from circle to ellipse to parabola to hyperbola. Okay, what happens if I do this? It's in the wrong side. Yes, it's in the wrong side, not in here. This is not. We go in here. Yeah. But this is also not what I had in mind. It's kind of very interesting, I gotta admit. Wow. I love my life so much. Ah! Okay, I think that will conclude for today's live stream. The reason why I did so many crazy things about the hyperbola ellipse and the other things is because today might be the last time I'm gonna be doing stuff about those curves. Yes. The shift to the mathematics content for this live stream is that I kind of want to, like, even just scratching the surface. Even the scratching the surface is okay. Is allowed for myself. I kind of want to, like, explore more depths into the mathematics, not just limited into high school level. The ones that learn in the university or some, like, Einstein, von Neumann degree level of mathematics. And I cannot just stuck in here playing with GeoGebra with this. I don't know what to call this. This is more like a. Yeah. Okay. Okay. I kind of wanted to break phrase. I just want. Minus. Oh, wait a minute. You know what? This is actually kind of spoiler. I kind of have my list of what I had in mind that I will do in the future. One thing is that I will going to be finding an equation, a function of the triangular and pulse waves. And this is totally like coincidence, accidental. Anyway, yeah, we're gonna do that later. But for now we're really going to say goodbye to the ellipse, circle, parabola, and hyperbola. We might come back for different reasons, but in the next live stream, we will not be talking about this subject. We'll be talking about something else. I'll bring up the different one, a different subject, to indulge your mathematics senses. Okay. See you next time.